So now that we've gone over these scenarios, what I'd like you to do is consider what types of problems come up within a scenario. So we talked about data gathering problems, right? When we gather data from the crowd or other places. Some data bias that can happen when we use incomplete or some other data that might not be able to guarantee that the model that we learn fits the problem that we're trying to actually do. Problems with privacy, where data that we have might inadvertently affect ourselves or others around us. Problems when we use big data and machine learning models, because when we have so much data and we have users using those data as end users, the platform can offer itself as a vector for attack. Difficulties with confirmation bias, in the sense that the platforms are now customizing what we see and what actions that we can take, and that can further enhance our belief that our own actions are right without needing to consider other people's ideas. We see this all the time now, where certain media outlets, because they're becoming personalized, self-reinforce our own beliefs instead of exposing us to contrary beliefs that let us think more deeply about the problem. And that whatever type of system we engineer, sometimes our systems will have to have moral values inculcated in them, even if it's not explicitly stated, because the actions that our algorithms take can actually have real world or virtual world effects that affect real people. And that the societal use of machine learning systems, coupled with things like data bias from up here, admits the differences between validation and testing compared to training, may have a profound effect on inequality of how our machine learning algorithms are used and the quality of results that they have. So with all of this in mind, the last activity that we have for you in this entire course is to think about one of these issues, okay? So we'd like you to pick one of these issues that we saw on the last slide and link it back to machine learning. What things can we do to either enhance the awareness of these issues or to try to mitigate their damaging effects through algorithmic considerations. So you can think about any one of these issues and connect it to what we've learned in any part of the course, or better yet, in certain cases, you may be able to relate it to your own project work. So as you've done a project in this course, maybe you can discuss in the collab notebook, okay, in coursemology assessments, how does it impact these issues impact your own project work. So to do this, you can illustrate a dilemma in which you might encounter that takes the form of the issue, and then in the writing that you've done, propose rules that you think somebody who's a data scientist or a machine learning scientist should follow when encountering these types of dilemmas, okay? And there are a whole set of slides in the rest of this section that I'm not going to cover in much detail that you can use as a reference in order to address this. So you can stop here if you'd like, but if you want to continue, I'll just briefly go over the rest of the slides. So those of you from NUS will have taken IS 1103, Computing in Society, which is our core ethics and computing course that has to deal with the societal implications of IT. And in this course, we look at 3 different principles in part. The principle of utility, say that the action is right to the extent that it increases happiness in the society. Kantianism, which says that we might want to decide what type of action to take only from moral rules that we can universalize, or subjective relativism, saying that somebody's interest may not be in other people's interests, and what's right for you may not be right for someone else. So these three different principles predicate how we might want to decide our systems to decide what action to take. Now, the Data Science Association also has written a code of conduct, which is really important to take a look at. And in part, I've pulled out two particular clauses, which I think are very relevant to this particular exercise on ethics and ethical dilemmas, right? So it says here, a data scientist should use a reasonable amount of diligence to detect, recognize, disclose, and factor real or perceived and potentially hidden risks using data scientists. So we can debate about what we mean by reasonable and how we are going to do these activities here: detect, recognize, disclose, and factor in different risks. Okay. Also here we have the case of the data science method, right? So making sure that we have careful observation to address data bias. Okay. Careful consideration of how we are going to manufacture meaning from the data. Okay. Perhaps through machine learning models. Okay. But not just the machine learning model, but the underlying data with it. So for example, when we have sparse data, we might grossly overfit, and that means our machine learning model, even though it's trying to do its best possible, shouldn't be relied on. Okay? And the formation of hypotheses, like we were just discussing, and also experimental or observational testing of the validity of the hypothesis. So when we have training data and it's not actually equal to our validation or our test data, we have a big problem, right? So for example, if we test on pale faces, but we have our training data is only for people with dark skin tone, then we'll have some problematic results that we might not be able to recognize a face, for example. So a corollary to that is when we're trying to design, create, or implement machine learning systems, right? So we have to also think about these problems, right? So we build a system, we have to have full disclosure and to tell our clients, because they may not be experts, we might be executing a machine learning project on behalf of a client, whether to trust the machine or not, right? So in many cases, because we can always make the excuse, hey, the data doesn't lie, that's what the data says, just take it, that's the optimal decision, that is not placing a value judgment on what we are doing. And so as machine learning scientists and data scientists, we have to make that decision about whether we believe the machine learning algorithm should be let loose and allowed to make decisions autonomously or with consent and with an advisor, a human advisor in the loop. Okay. Also very importantly, we have to make sure we don't cherry pick, okay? Meaning just don't point to the goodness of our machine learning system, but again, have full disclosure about the problems when there is bias in the data or bias towards particular classes, which it may do better on or worse on, okay? And that a data scientist should not present incomplete evidence as real data science evidence. We have to have the full training distribution in order to understand the properties of the algorithm, and we have to know whether that distribution matches our testing distribution. So for sharing data, we also have to think about this, right? Making sure that we share data to make it transparent so somebody else can re-engineer the algorithm given the data, have a clear idea of where that data came from, and especially in the case of health or also in the case of education, which is one of my interests, you know, putting learner data like the ones that you've been producing in Coursemology to help future learners, making sure that ethical and equitable access to that data is fully disclosed. So if you don't want the data that you have used in Coursemology used for future instances, I have to let you know whether that's going to be the case, okay? And then also ensuring the quality of the collected data and holding sources accountable for the case where low quality data was created, and making sure that we have appropriate warning flags up when people are going to use such data. So, as I've pointed out to you, machine learning is a very hot topic and very important in today's age. But we really have to think about this broader concept way beyond the mathematics of the course, right? Because machine learning is not just a mathematical model, because we actually use it. It impacts people's lives, including yours, right now. When you're using YouTube, or you're using Gmail, or you're using any of the properties on the internet, whether in China or in the Western countries, all of these are generating data, and that data is being, of course, mined to create better machine learning systems. So we need to make sure that the policy and the ethical procedures are in place, so that when we have things like big data and AI, that we use them in a way that's going to advance our civilization and help to promote what we think are the societal values. So speaking of values, we have to think about at this from a very human-centric standpoint, so we can invoke the idea of value-centric design, or value-sensitive design, to think about how does architecture and implementations of the systems that we build today, what impact they have downstream, okay, on all of the different stakeholders, not just the direct stakeholders. For example, when you post on social media, you're not just affecting the lives of yourselves and your friends, but also potentially the people who are in your photographs, or the people who you tag, that may not be directly value the announcements that social media might give. Okay? And some of these have ramifications over time, right? So if you have a machine learning system that tries to propagate information, that exponential speed up in information propagation can cause a lot of damage very quickly, and have difficulties over time, right? The values criteria means that different groups might have different values of interest, okay? And to think about all of the different aspects of which value is latent into a machine learning system. And the final aspect of pervasiveness is to think about how these systemic interactions that come about interact with each other. So one machine learning system is not engineered in a vacuum. It may interact with other systems on the same platform or across platforms. And many of us, when we do machine learning in a vacuum, don't realize that other systems are affecting those outcomes. So to close our entire course, let me first thank you for participating in our machine learning course, but also close with a warning. As I've said, this is the most important lesson in the entire course, because this is where we have the least development, our least knowledge, because there's a human in the loop. It's not just math or stats that's helping us decide what to do. We must take responsibility for the safeguards of the technology that we are enabling through the production of machine learning in society, and that very soon many of us will be tested in our work environment. We are going to use machine learning. We may be using crappy data. We may come up with models that are no good, and it is our call as graduates of this program to decide what is the correct thing to do, what is the right decision to make to put this machine system that's learned into practice, or to whistleblow and say, hey, look, even though we can do this, this is not the appropriate action to take. Remember to think through your consequences. In fact, there have been many alumni in our courses who found that a reminder of this sort helps them very much when they come to the ethical dilemma that may be facing you, yourself, in 3 to 5 years' time or farther in the future. So here I'm going to stop and ask you to think about the rest of the lecture after you've gone through the Collab notebook, and then continue on with the rest of the bias part of the lecture.